Hello, this is Mickey Park from IB The Top, and we're going to go through November paper, November 24, paper 1, higher level. Let's go. So, this is question 1, the geometry question. We're given a diagram of a sector, and we are also given the angle in between, okay? That's 1.5 radians. And let's move on to part A. So part A shows that the area of the sector is 48, and we're asked to find the value of r. And given the sector, how do we find the area of a sector? The area of a sector is basically a proportion of the full circle. What's the angle of the full circle? It's 2 pi. And it's a portion of 2 pi, so it's 1.5 over 2 pi multiplied by the whole area of the circle, which is pi r squared. And if we cancel out the pi's, and I have 1.5 over 2 r squared. And we know that this is equal to 48, given by the question. So r squared is equal to 48 times 2 over 1.5. If I do quick maths, I'm going to rewrite 1.5 as 2 over 3, which is multiplied by 3 over 2. Sorry, 2 over 3, because it's a multiplication. And that's equal to r squared. And if I just cancel out, then I have 16, and hence this is 16 times 4, which is 64. And finally, we have our final answer to be r is equal to 8. Well, r squared is 64, r is plus minus 8, but we omit the minus sign because the radius can't be negative. Let's move on to the perimeter part, where we have to find the perimeter of the sector. So that is, given the radius, and the length of the arc, that is, the perimeter is basically 2r plus L. That's what we're looking for. And how do we find L? L is given by the formula theta r. So we have 16, which is 2 times 8, plus 1.5 times 8. And 1.5 times 8, that is 12. So our length of the perimeter is 28. Okay? All right, let's move on to the second question. The second question is about probability. We're given the probability of A, we're given the probability of B, and the union of A and B. And we are further asked to find the intersection of A and B. If I were to illustrate this on using the Venn diagram, that's how I'm going to write it. So I have the whole probability of A and the whole probability of B. And if I were to add the probability of A and probability of B, I have this intersection part added twice. So that means I can derive another formula from here. The union of A and B is nothing but the probability of A plus the probability of B minus subtracting the intersection, because it's added twice. So from the given data, 0.85 is equal to 0.65 plus 0.45 minus the probability of the intersection. Switching things up, I have the probability of A intersecting B on the left-hand side, and that is 1.1 minus 0.85, and that is 0.25. Okay, that is our final answer. Moving on to the part B. Part B asks to find probability of A prime bar B prime. This is the conditional probability. Using the formula of the Bayes theorem, I can rewrite this whole thing as the probability of A prime bar B prime is equal to, the denominator is always going to be the condition, which is B prime, while the numerator is going to be the intersection of the asked probability and the condition, which is the probability of A prime intersecting B prime. Well, I can rewrite the top as probability of A union B all prime divided by 1 minus the probability of B, right? Because this is just a little hack where you can rewrite, you can take out the prime, you can switch the intersecting with the union. If it were union, you can change it to the intersection. And then the prime, you can take it out all in one bracket and then switch the sign, okay? And what was the probability of the union? It was 0.85, so that is 1 minus the 0.85 over 1 minus 0.45. And that being said, if I were to just continue this here, I have 0.15 over 0.55. That is, if I were to cancel out, I have 3 over 11. So my final answer is 3 over 11. Okay? And let's move on to the next question. The next question is a proof. We have to prove that blah, 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 blah is a multiple of 12 for all positive integers. If we were given that something is a multiple of 12, that means I can rewrite this whole thing as 12 times a, where a is just any integer, okay? And that is our aim, to express the whole thing, all of this, into a multiple of 12. Let's try that. So let me just expand this. I have 3n plus 2. I have a habit of rewriting the question. Let me just expand that. Now, applying the formula, I have 9n squared plus 12n plus 4 minus, all in the bracket, 9n squared minus 12n plus 4. And if I were to simplify this, these will cancel out, and that will be, this will also cancel out. So I have 24n. Well, I can rewrite 24n as 12 times 2n. And hence, this is a multiple of 12. That is how we show that this is a multiple of 12. Okay, let's move on to the next question, please. Question 4, it's another trigonometry question, a very classic one. We're given the triangle ABC, we're given the length of all 3 sides with the angle of ABC given to be 2 theta. And we're asked to find the exact value of cosine theta. That means you're not allowed a calculator, although you don't have a calculator for paper 1. Yes, so if we have 3 sides, if we're given all 3 sides of the triangle, using the cosine rule, we can basically find all 3 angles. So let's try using the cosine rule. Since I'm using this angle right here, 2 theta, I'm gonna use 5 as the opposite. So that means applying the cosine rule, which is, let me just rewrite the cosine rule. It's a squared is equal to b squared plus c squared minus 2bc cosine a. Okay, and this a here is going to be our angle 2 theta. So we have 5 squared is equal to 4 squared plus 6 squared minus 2 times 4 times 6 cosine 2 theta. If I were to just expand that, I have 25 is equal to 16 plus 36 minus 48 cosine 2 theta. Okay, and simplifying that, since I know this is 52, moving to the left-hand side, I have minus 27, okay, minus 48 cosine, 2 theta. Then I have cosine 2 theta to be 27 over 48. Let me just simplify this. Always, it's a really good habit to simplify your fraction or whatever you have, your equation, before you move on to the next step, okay? This I can divide by 3, so I'm just going to divide that. So it's 9 over 16, okay? But we're not done. We're asked to find what cosine theta was, not cosine 2 theta. So if I just continue here, this is another formula for trigonometry. We can apply the double angle formula. where cosine 2 theta is equal to 2 cosine square theta minus 1. So that is equal to 9 over 16. So 2 cosine square theta is equal to 25 over 16. And cosine square theta is equal to 25 over 32. And so cosine theta is square root of 25 over 32. Of course, I can have plus minus. I should have plus minus if it were just algebraic equation, but I should not here in this case because we're told that P and Q are positive integers, okay? And we're not done because we have to further simplify this. Then I have 5 over root 32. But root 32 is what? Root 32 is 2 to the power 5, so that is 5 over 4 root 2. But we're still not done. We have to have the root 2 on the numerator, so that means we have to rationalize this. If I just can move this here. Rationalizing, multiplying by root 2, top and bottom. I have 5 root 2 over 8. And that is our answer, where P is equal to 5 and Q is equal to 8. Okay? All right, let's move on to the next question, please. It's an algebra question, sequence in a series. We're given U10. U10 is equal to 16. U10 means it's the 10th term of the particular arithmetic sequence. And S25, that means it's the sum until the 25th term in the arithmetic series, okay? And the formula for that is UN is equal to U1 plus N minus 1D for arithmetic, while Sn is equal to N over 2 U1 plus N minus 1D. We're going to make use of these two formulae. I'm going to put it up here, okay? So, U10, I can express this as 16 is equal to U1 plus 90, while S25, I'm not going to write S25, 100 is equal to 25 over 2 U1 plus 24D, okay? I have two equations, two unknowns. If I were just to simplify this before I do the simultaneous equation, I have 200 over 200 is equal to 25 over, 2U1 24D. Well, I think I can just plug in the divided by 2, the over 2 one here. I think that will simplify things more. So 4 is equal to U1 plus 12D. So I've divided both sides by 25. I think that was way quicker. And solving these two equations simultaneously, I can move this here. This is a good thing about iPads where I can just switch things around. All right, and subtracting, I have 12 is equal to minus 3D. So D is equal to minus 4. All right, but D is not what we're asked to find. We're asked to find UK we're asked to find what K is where UK is equal to 0. But in order to do that, I still have to find what U1 is. Let's try to find what U1 is. Subbing this whole thing into this equation. Then I have 4 is equal to U1 minus 48. Then I have U1 to be 52. Okay? And with these, I can find UK. UK is nothing but 52 plus K minus 1 multiplied by negative 4. And we are told that this is equal to 0. So that means 52 minus 4K plus 4 is equal to 0. 56 is equal to 4K, and K is 16. And that is it. Okay? That wasn't too difficult, but the tricky part of this question is to know how to formulate these two equations and try and solve this simultaneously. This is a very classic question, okay? Always try to solve the simultaneous equation, formulating two different equations with two different variables. All right, moving on to the next question. Well, very simple, very straightforward. Solve blah, blah, blah. This is a quadratic inequality, right? To solve the quadratic inequality, I suggest you graph it, okay? So, 2x squared minus 15x plus 18 is a happy face, right? I mean, there's two different types. There is a happy face and a sad face. Given by the formula, the general form of quadratic equation, which is y is equal to ax squared plus bx plus c. If it's a happy face, that means a is greater than 0, which is the coefficient of the highest power. And if it's a sad face, that means a is less than 0. So, in this case, it's the happy face. So, I still need to find, given the x-axis, I would try to identify these two critical points. And let's try, in order to find the critical points, that means I have to equate the whole thing and find the x-intercept. So 2x squared minus 15x plus 18 is equal to 0. And we need a little bit of a trial and error. I'll try to do 1, 2, and 3, 6. Crossing, that gives 6 and 6. That does not work, so I'll have to try again. I have 1, 2, I'll try 6, 3 this time. I have 12 and 3, and adding them, I get 15. But what I need is minus 15. So what I'm going to do is put a minus there. So it'd be minus 12, minus 3, and minus 15. So we do have the factors. That means I can rewrite this whole thing as x minus 6, 2x minus 3 is equal to 0. So our critical points are when x is equal to 6 and when x is equal to 3 over 2. So on the number line, I have 6 here and 3 over 2 there. Of course, we know that 6 is bigger than 3 over 2, so it should be on the right. And to solve the inequality, we're told that this whole thing, this is less than 0. Less than 0 means it's under the x-axis. It's going to be this range. So our final answer is when x is in between 3 over 2 and 6. That is our final answer. Okay. Moving on to part B. We're given the function f of x, blah, 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 blah. This is the one that we just factorized. X is a real number, and x is x is less or equal to k. And we want to find the greatest value for which f minus 1 to exist. So in order for the inverse to exist, that means whatever it's in the f of x should be valid. It should be a function. It should pass the vertical line test. And if I just, from our knowledge of part A, we could have factorized the given function, the given equation, to be x minus 6 and 2x minus 3, right? And that looked something like this. We have 3 over 2 and 6. Because we cannot have any negative value inside the root, right? Root of negative, of course we can have complex numbers, but we're given that x is real parts, right? So that means we cannot have any negative values, and hence k is equal to 3 over 2. That is the greatest value. I mean, if it goes beyond that, I mean, from this range from 3 over 2 to 6, it will be negative. So the function will not be valid. And hence, k should be 3 over 2. Okay. All right, let's move on to the next question. Next question is, consider the function f of x. We have a secant x minus pi over 4. What is a secant? Secant x is nothing but 1 over cosine x, okay? So that means I can rewrite the whole thing. F of x is equal to 1 over secant x minus pi over, that doesn't look like, x minus pi over 4. And we're also given the range. And we're gonna find the range of the whole thing. And in order to find the range, because we know that the cosine itself, the cosine function only varies from -1 to 1. And that means it will have, it's periodic. It will repeat every 2 pi for an original cosine x. But we are restricted the domain from 0 to pi over 2. And we are given this secant x minus pi over 4 function. And we're going to evaluate 3 critical points where it's the minimum or the maximum, where it can be the minimum or the maximum. Those points are when when x is equal to 0, when x is equal to pi over 4, and when f is equal to pi over 2. Those 3 are the critical points, right? And let's evaluate what's f of 0. So that is 1. Oopsie, I made a mistake there. It shouldn't be secant. It should be cosine. That was pop quiz. Okay, so f0 is 1 over cosine minus pi over 4, and that is root 2. And f of pi over 4 is 1 over cosine 0, so that is just 1. And f of pi over 2, which is 1 over cosine x minus pi over 2, oopsie, pi over 2, minus pi over 4 is nothing but, so I'm just going to write it below, 1 over cosine pi over 4, well, that is just root 2 again. So it looks like it varies from 1 to root 2. That is our range. Okay. All right. Moving on to part B. The region bounded by the graph, blah, 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 x-axis and the line x is equal to 0 and x is pi over 2. Rotated 2 pi radians about the x-axis. Rotating about the x-axis, we have to find the volume. We're given the formula, and this is all in the formula booklet. Whenever I say there is a formula, it's all in the formula booklet. But I do highly encourage you to remember all these formulas. Of course, there are some formulae that even I don't remember. It saves a lot of time. So I highly encourage you to remember all the formulas. Okay. All right. And the volume for the rotation about the x-axis is pi integral from a to b. Well, this is the restrictions, the boundary. F of x all square dx. Well, we can just sub in. It was pi from 0 to pi over 2. What was our given form? Secant x minus pi over 4. So it was secant x minus pi over 4 dx, but all square. So I'm just going to put a square there. All right. And if you were to integrate secant square, you get tangent, right? So this is pi tangent x minus pi over 4 from 0 to pi over 2. No plus c, okay, this is a definite integral. We don't need any integral constant. So we just have to solve that. So it's pi of tangent, just gonna, pi of tangent x minus, pi over 2 minus pi over 4 minus tangent minus pi over 4, because it's 0 minus pi over 4. I'm just going to omit that. And what is tangent? Because we know that this is pi over 4. Tangent pi over 4 is nothing but 1, right? This is standard angles. You have to remember the standard angles. So it's pi 1 minus tangent minus pi over 4 is minus 1, right? So this whole thing is minus 1, but it's minus 1, so it's a plus 1. So our answer is just 2 pi. That's the volume of revolution about the x-axis. All right, moving on to the next question. Question 8, a vector question. We are given that OA, vector OA is A, and OB is denoted as B. And I want to find OP, okay? And I want to express it in terms of A and B. And we're further noticed that AP is equal to lambda AB. Well, this basically means that P is on the line AB, where that means AP can be represented as a multiple of AB, right? It's a factor, since lambda is just a scalar. It's a multiple of AB. So when you're doing vector questions, a vector is very convenient in that it's just finding a root, okay? So OP basically means you start from O and you end at P. So OP, you're basically starting from O, ending at P. That is what? That is OA, you go to OA, and then AP. So I can rewrite it like this, while, that O is a little ugly, OP, okay? And OA is denoted as vector A, and AP is told to be, told to be lambda AB. Now we have to find what AB is now, okay? That's another task we have. So let's try to identify what AB is. Again, vector AB is starting at A, ending at B. So what is that? I can just do, in order to start at A and end at B, let me just use a different color. You start at A, end at B. I can go AO and OB, right? So I can rewrite this whole thing as AO plus OB. What is AO? Since OA was vector A, that means AO is minus A, and OB is just B. So we derive that vector AB is minus A plus B, and substituting that in, I have vector A plus lambda minus A plus B. It looks like a T. Let me rewrite this whole thing. Plus B, right? And if I just factor out the A's, then I have 1 minus lambda vector A plus lambda B, which is the required form. Okay, this is how you show. This is how you show that question. Okay, you manipulate the left-hand side, blah 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 blah, to right-hand side. You never touch the right-hand side beforehand. Okay, that's not how you do a proof. If you do that, it will be a circular reasoning. Anyways, moving on to part B. We are further given that the modulus of A is 1, modulus of B is equal to 2. That's the absolute value. That's the length of the vector. And A dot B is 1 over 4. And we are also told that OP is perpendicular to AB. If they're perpendicular, that means the dot product of the two vectors is equal to 0. So OP dot AB is equal to 0. And what was OP? OP was what? OP was, using the given information, 1 minus lambda A plus lambda B. 1 minus lambda A plus lambda B dotted with AB. What was AB? AB was minus A plus B. And that is equal to 0. Okay? And of course, had you not figured out how to solve A, right, you can still attempt B. This is a good thing about IB. When they do show that question, they're trying to help you. They're still trying to force you to move on to the next question and use the given information in the previous question to solve the latter questions. Okay, so never give up. All right, so this is a dot product. I can expand. That means I have 1 minus lambda A, oopsies, 1 minus lambda A, dotted with minus A plus 1 minus lambda A with dotted with B. That is very hassle. Dotted with B plus, minus lambda A dot B plus lambda B dot B is equal to 0. That is just simple expansion. And I have, since this whole thing, before we move on, I think we need to go through this. A dot A, in theory, is just going to be vector modulus of A cosine theta, right? That's the dot product. So this is nothing but the modulus A squared, because theta is going to be 0 in this case. There is no difference in the two vectors. They're identical. So here I have vector A dot 2 with vector A, that means it's just a modulus, okay? Modulus square. So I can rewrite this whole thing as minus 1 plus lambda and modulus A square, okay? And then plus 1 minus lambda. We are given, I'm just going to rewrite this, vector A dot B minus lambda A dot B and plus lambda, similar to the previous A dots, that is equal to 0. So I can sub in the values, minus 1 plus lambda, the modulus of A is 1, so 1 squared is just 1, plus A dot B is 1 over 4, so it's minus 1 lambda over 4, minus lambda over 4, plus 4 lambda, and that is equal to 0. Now it's just simple algebra. If I were to continue it here, whew, that's a lot. I'm going to multiply everything by 4, minus 4 plus 4 lambda, because I hate fractions, plus 1 minus lambda, plus 16 lambda is equal to 0. I can simplify this, adding all the like terms. I have minus 3, and that is minus 2 lambda, plus 18 lambda is equal to 0. And that means 18 lambda is equal to 3. Well, lambda is equal to 6. And that is how we do the question. Oops, my bad, made a mistake there. Lambda is equal to 3 over 18. Well, it's just 1 over 6. Okay. And we are going to move on to the next question. This is our last question of section A. Well, as you know, paper 1 is divided into section A and section B. Section A is more of a smaller questions, whereas section B is the big, fat, chunky ones. And this is the last question of section A. So prove that tangent blah, 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 blah. So in order to prove that question, again, if I repeat myself, you have to, it's very similar to the show that question. You have to manipulate the left to make it look like the right. So I'm going to make use of the formula. Tangent A minus B is equal to tangent A tangent B 1 plus tangent A tangent B. I'm going to make use of that formula. So I have, oopsies, this should be not that. It should be minus tangent A tangent B. This is in the form booklet, so it's just my memory. Okay, so tangent theta minus pi over 4 is equal to tangent theta minus tangent pi over 4 over 1 plus tangent theta tangent pi over 4. Well, it's very convenient, very kind of the IB to give such angle, because tangent pi over 4 is nothing but 1. So it's tangent theta minus 1 over 1 plus tangent theta. Okay? I'm going to rewrite tangent theta into sine theta over cosine theta. Why? Because our result has a sine and cosine in it. So it's a little bit of a cheat, okay? So I'm gonna look at the right-hand side, midway of the proof, and say and determine which path I'm gonna take in expanding. So it's sine theta over cosine theta minus 1 over 1 plus sine theta over cosine theta. I'm running out of space. To expand this, then I have sine theta minus cosine theta over sine theta plus cosine theta. And here what I'm going to do is I'm going to multiply, again, both sides, top and bottom, by sine theta minus cosine theta. Then I have sine squared theta minus cosine squared theta, which is equal to, and the top is sine theta minus cosine theta, all squared. Because I'm running out of space, I'm going to write here. Because we want to make cosine 2 theta the bottom. And we acknowledging that cosine 2 theta is equal to cosine squared theta minus sine squared theta. I can try to make it like that. So I can try to put the minus sign at the top, okay? And then make the denominator cosine 2 theta already. So here's, it's like matching a puzzle, you know? It's like solving a puzzle. So now I have to just solve the puzzle for the numerator. Let me expand that. I have, oopsies, minus sine squared theta minus 2 sine theta cosine theta. I'm going to remove that, I'm running out of space, plus cosine squared theta, okay? Now, what is sine squared theta cosine squared theta? When added together, that gives 1. That is a Pythagorean identity. And we know that we know that 2 sine theta cosine theta is equal to sine 2 theta. From here, that's double angle formula. So I have minus sine 2 theta plus 1 over cosine 2 theta. Our final answer is sine 2 theta minus 1 over cosine 2 theta. That is our final answer. I kind of went here and there. Hope that made sense. Okay. Moving on to the part B, we have hence, right? Hence means that we have to make use of whatever we have in the previous question. Well, they did say otherwise, so you are allowed to use other methods, but I do strongly encourage you to just stick with the previous question. So we need to solve this, and they said hence, so I'm gonna try to go through whatever we had to prove in the previous question. And don't they look similar? The whole thing, the one that we have to solve. So basically, when x is equal to 2 theta, we have sine 2 theta minus 1 over cosine 2 theta is equal to root 3. Well, this looks pretty similar to what we just did. That was tangent theta minus pi over 4 is equal to root 3. But when we change the variables, we also have to change the range. So that means, since we're given that x is from 0 to 2 pi, basically theta is x over 2. So our permitted range for theta is from 0 to just pi. Okay, bearing that in mind, let's move on. So if tangent of something is equal to root 3, that means from the standard angles, it is the angle theta minus pi over 4 should be what? It should be pi over 3. And since tangent is periodic by pi, so it's 4 pi over 3, 7 pi over 3, ... But because of our range, bearing that in mind, we have to reject these two. Why? Because they go beyond our range. And hence, theta is equal to pi over 3 plus pi over 4, so that is 7 pi over 12. But do not leave your answer like this, okay? You are not asked to find what theta is, but instead x. So x is equal to, since it's 2 theta, we just multiply by 2, we have 7 pi over 6, and that should be our final answer. So this is the end of section A. We're going to come back to section B in a minute. Welcome back. We're going to start doing the questions from section B. Section B is always from 10 to 12. They're the fat ones, they're the chunky ones, they're the time-consuming ones. So I suggest by the end of the preparation of the finals, you should be able to finish the section A relatively quickly and then spend more time on section B, because they're usually the more complicated ones and challenging. All right, so we can move on to this question. Question 10, we're given a cylinder, another geometry question in fact. We're given a cylinder, radius of 4r, height h, and we have a smaller cylinder removed, so to make a hollow cylinder. And let's move on to the question. The question suggests we need to find the volume, okay? That's what we have to find, given, we have to find the surface area given by S, and we have to show that this is blah, blah, blah. Again, This is what I was talking about. So when they give you the show that question, when S is equal to blah blah blah, they don't ask you to find what the surface area is, but in fact they give you the surface area and then ask you to show that this is equal to that. The reason being is because you may need to use this value in the latter question. So don't give up if you get stuck on part A, okay? Well, you shouldn't get stuck in this one. This is a relatively easy one. So it's a total surface area. If you think about the total surface area, it's going to be the whole of the base of the cylinder, right? There's two base, minus the smaller cylinder's base. So I'm going to do like this. 2 times the big base minus 2 times the small base, right? And then plus, what do I have to add by? I have to add by the big circular curved surface plus another the curved surface on the inside, right? So let's do that one by one. The big circle is 2 times pi r square, so it's pi 4r square, minus 2 times pi r square, plus, what's the curved surface? It's going to be the circumference, which is 2 pi 4r h plus 2 pi r h. Let's simplify that. That is 2 pi 16r square minus 2 pi r square plus 8 pi r h plus 2 pi r h. Further simplifying that gives 30 pi r square plus 10 pi r h, which is the required form. Okay, moving on to the next question. Here, they ask you to find what the volume is, given the total surface area to be 240. So, here, that's when we make use of the given equation. S is equal to 30 pi r square plus 10 pi r h. So, 30 pi r square plus 10 pi r h is equal to 240 pi. And here we can acquire an equation relating r and h. So I will try to find what h is. Let me just cancel out the pi's because I want my equations to be as light as possible. I can further cancel out the tens as well, right? So I have 3r squared plus 10rh is equal to 24, okay? And what can I do? I can further express h to be 24 minus 3r squared all over 10r, right? And let's try to find the volume. What's the volume? The volume is the big cylinder minus the small cylinder. So it's the big cylinder minus the small cylinder. And what was the formula for all these? It was pi r squared h, right? And the formula for the big cylinder is pi 4r squared h. Oops. Sorry, can I start again? For this part. Sorry. Okay, I'm ready. All right, so this is part B. We are asked to find the volume in this case. Again, this is a show that question. Of course, they could ask you to find what the volume is, but instead they chose you to prove that this is true. And we are further given the surface area to be 240 pi. So what is V? V is the big cylinder minus the small cylinder, right? I should have made the height equally, but my terrible drawing. So it was, what's the formula for the cylinder's volume? It's pi r squared h, right? So that is pi 4r squared h minus pi r squared h, right? And I can simplify that as 16 pi r squared h minus pi r squared h, which is just 15 pi r squared h. But we're not done. We have an H here while they don't. So that means I have to find my way to express H in terms of R. So let's do that. How do I do that? I have to make use of the given information that the surface area was 240 pi. So the surface area, what was the equation of the surface area? 30 pi r squared plus 10 pi RH is equal to 240 pi. That's the given equation, right? I'm going to cancel out the pi's because I can. I want my equation as light as possible. I'm also going to divide everything by 10. So that removes all the zeros, and I have 3r squared plus RH is equal to 24. And that means I have RH is equal to 24 minus 3r squared, while H is 24 minus 3r squared all over r. That's my equation of the H. So let's try to sub in. Subbing that, oopsies. Subbing that gives 15 pi r squared multiplied by 24 minus 3r squared over r. Now I can cancel out the r as well. So this is 15 pi r 24 minus 3r squared, and expanding that will give 360 pi r, oopsies, 360 pi r minus 45 pi r cubed. Of course, it takes a lot of time to actually compute 15 times 24, but because this is like the third time I'm filming this, I already know that this is 360, okay? All right, moving on to part C. We need to find an expression for dV/dr. Very, very simple. From the equation, V is equal to 360 pi r. V was equal to 360 pi r minus 45 pi r cubed. We just have to differentiate it with respect to r. So dV/dr is just 360 pi minus 45 times 3 pi r squared, which is 360 pi minus 135 pi r squared. That will be our equation. Okay, that was too simple. And moving on to the next question, we have to find what r is when given that the volume is maximized. So to find the maximum volume, that means dV/dr is equal to 0. Of course, the volume that meets this condition is going to be when volume is either maximized or minimized. We don't know, but we might have to sometimes further verify whether it's a maximum or the minimum. In the cases where we get two values of r, or two or more values. Well, let's try to solve this question if we have to do the further verification. So dV/dr was previously found to be 360 pi minus 135 pi r squared is equal to 0. And let's try to solve this to find the value of r. That is 360 pi is equal to 135 pi r squared. I'm gonna cancel out the pi's, and I'm gonna cancel out both sides by 5. Okay, that means I have 7, I have 72. Okay, so that means r squared. I can further simplify this. I can divide both sides by 9. I have 3 and 8. So that means I have r squared is equal to 8 over 3. So hence, r is plus minus root 8 over 3. But we are told that the p is a positive integer, so I'm going to reject the negative sign. So I have r is equal to root 8 over 3, and that means r is 2 root 2 over 3, right? Because I can take out the factor of 8, which is 2 root 2. Hence, p is equal to 2. Okay. And moving on to the last question. Hence, again, another hence question. They said find the maximum volume, giving your answer in the form blah, blah, blah. Okay, and we need to find the maximum volume. So that means basically V find v when r is equal to, what was it? 2 root 2/3. So let's try to find the volume in that case. What was the equation for the volume? The volume was 360 pi, what was it? What was the volume? We just have to go back. 360 pi r minus 45 pi r cubed. Pi r minus 45 pi r cubed. We just have to sub in. So that means I have 360 pi and multiply by 2 root 3 minus 45 pi 2 root 2/3 cubed. That is very tedious, but let's just continue. So that is 720 pi root 2/3 minus, that is 45 pi multiplied by 8 multiplied by 2/3 multiplied by square root of 2/3. Does that make sense? Because if it's to the power of cubed, right? If it's to the power of 3, I can literally take out the squared versions. And then, to continue, I have, let me just simplify this before I move on. Then I have what? 720 pi minus, what's 15 times 16? 15 times 16, I'm just going to skip. 16 times 15 pi, all root 2/3. That's what it is. So 15 times 16 turns out to be 240. So 720 pi minus 240 pi root 2/3. And hence we have our answer to be 480 pi 2/3. And that is our final answer. Okay? All right, let's move on to the next question. Question 11, another differentiation questions. A curve given by y is equal to blah, blah, blah. We have to apply the L'Hopital's rule to show that limits blah, blah, blah is equal to 1. So let's try to find the limits of it, limits of y. So limits when x tends to infinity. We have e 2x minus 1 over e 2x plus 1. When we try to solve the limits, we basically try to sub in whatever the x is tending to. When we sub that in, what do we get? We get infinity over infinity. So that's how we can apply the L'Hopital's rule. The L'Hopital's rule states that if it's infinity over infinity, we can do f prime of x over g prime of x, right? This is the same thing. This was L'Hopital's rule. So I'm going to differentiate top and bottom respectively. Then I get limits x tends to infinity 2e2x over 2e2x, which cancels out. And then I have 1. And that's how we show that this is equal to 1. Okay? Moving on to the second question, show that dy dx is blah, blah, blah. I just brought this here for you. To differentiate the given equation, what we can do is apply quotient rule. So let's try to apply the quotient rule. So dy dx, using this equation, okay? Then I have e2x plus 1 square, that's a quotient rule. And I have to differentiate the top first. Then I have e 2e 2x multiplied by e 2x plus 1. I'm just going to move everything a little down. And then minus, what do? I have to differentiate the bottom. 2e 2x e to the 2x minus 1. Let's just expand that. I have e 2x plus 1 square, and I can just factorize this. 2e 2x e 2x plus 1 minus e 2x plus 1. Then I get this 2 cancels out. Now I have 4e2x all over e2x plus 1 all square, which is the required form. Not too difficult, that's just simple quotient rule. But many students tend to make a mistake when they expand the minus sign, okay? So be careful. And let's move on. Moving on to the next question. Hence show that blah, 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 blah. So it's a hence question. So what is 1 minus y squared? 1 minus y squared was what? Because we know that y is this, right? We're going to sub that in. 1 minus e2x minus 1 over e2x plus 1 all square. And we just have to expand that. So let's expand it. 1 minus e2x minus 1 square. I can split this into 2 big chunks. Okay? And then let me just, I need a little more space. I'm just going to do that. And because it's 1 minus a fraction, I'm going to make them the same denominator. Then I have e2x plus 1 square minus e2x minus 1 all square over e2x plus 1 all square, right? To continue it here, I can just expand e4x plus 2e2x plus 1 minus e4x minus 2e2x plus 1 all over e2x plus 1 all square. That's very tedious, and that cancels out. That also cancels out, and I have 4e2x over e2x plus 1 all square, which is the required form, which is equal to dy dx. Okay, that's how we show that this is true. Moving on to part C, by using implicit differentiation. Implicit differentiation is like, for simple differentiations, we had y is equal to blah, blah, blah. So we simply just did dy dx and then try to differentiate the right-hand side. But implicit differentiation means you're going to differentiate it with the y's included among the x, okay? So from part I, we had 1 minus y squared is equal to dy dx. Let's try to implicitly differentiate this. Differentiating term by term, 1 will become 0, and minus y squared is minus 2y dy dx is equal to d2y dx squared, right? So d2y dx squared is nothing but minus 2y. What was dy dx? dy dx was this, right? I can sub that in, 1 minus y squared, and hence I have minus 2y plus 2y cubed. That's how we show, all right? That conforms with the question. And the next question is, find an expression for d3y dx cubed. So you have to differentiate this again, right? In order to differentiate this, we can just differentiate again. That means d2y d cubed y over dx cubed is equal to 6y squared dy dx minus 2 dy dx, right? Implicitly differentiating with respect to x. Then I have 6y squared. What's dy dx? dy dx was 1 minus y squared minus 2 1 minus y squared, which is equal to 6y, sorry, I'll just expand it, okay? 6y squared plus 6y to the power of 4 minus 2 plus 2y squared. That simplifies to 6y to the power of 4 and plus 8y squared minus 2. That is our final answer. Okay, and moving on, then I've written this beforehand, okay? And we need to find the Maclaurin series for this. The Maclaurin series I've also added here beforehand. This is also in the formula booklet, so you can refer to it. So, applying the formula, y is basically equal to, or approximately equal to. We just have to find until x to the power of 3. That's why I only had until x to the power of 3, okay? Let's just sub in. So what was y is equal to 0? When y was 0, that was just, since this is y, right? Then I have e to the 0. Oh, you know what? Let's just try to find what y0 is and what y prime of 0 is, y double prime of 0 is, and y cubed 0 is first. I think that would be more convenient. So y0, that means e0 minus 1, e0 plus 1. So that is just 0. Y prime 0, we're using this equation here, sub in 0. That is 4e0 over e0 plus 1 all square. So that is 1, right? Because it's, if I just show you the full steps, it's 4 over 2 squared, so it's just 1, 4 over 4. And y double prime 0, it's this equation, right? So that is, we knew that when x is equal to 0, y is equal to 0. I'm just going to make use of this equation then. So that is 2 0 cubed minus 2 0. So that is just 0, right? And y triple differentiated is 0 minus 0 minus 2. So that is minus 2. Okay, now we have all the derivatives. We just have to sub it in. So y is 0 plus x plus, well, 0x squared, and then y cubed is minus 2. What's 3 factorials? It's 6x cubed. So expanding, that gives x minus 1 over 3x cubed. That is our final answer expressed using Maclaurin series. Okay. And the last question of today is question 12, a complex number question. Let's deep dive in. So we're given the equation z to the power 4 is equal to 16i, and it has 4 roots, z1, 2, 3, and 4. Where z1, blah, 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 blah. This is just a, a Cartesian format. Polar format. And we're told that theta 1, theta 2, they're in order in between 0 and 2 pi. And we have to find what z1 through z4 are. So this is basically the roots of unity, right? Let me express z to the power 4 in terms of the polar form. To do that, I have to find the modulus. Well, this is just 16. And the argument of z to the power 4. Well, if I were to draw the Argand diagram, 16i is here, right? So that's because that's the imaginary, that's a real part. 16i is somewhere here. That is 16. So the angle is pi over 2. So argument z4 is just pi over 2. Okay, so to express z to the power 4, it is 16 cosine pi over 2 plus I sine pi over 2. Okay, but when we want to find the roots of unity, we had to plus the 2 pi k, remember? So z to the power 4 is 16. I can also express the whole thing as like that, can't I? Pi over 2 plus 2 pi k plus I sine pi over 2 plus 2 pi k, because for every 2 pi, it doesn't change any value of the sign itself, because it, as you can see in the unit circle as well, it will just be repeating because they're periodic by 2 pi. And now apply the DMT, the de Moivre's theorem. Then I have z is equal to 16, 1 over 4, and then cosine pi over 2 plus 2 pi k over 4 plus I sine pi over 2 plus 2 pi k over 4. That is my z. Now what I have to do is I have to sub in the values of k from, let's just try to sub in from k is equal to 1. When k is equal to 1, what is z? Z is 2 cis. I'm just going to use cis for short form. Cis pi over 2 over 4. So that is 2 cis pi over 8, right? And when k is equal to 1, z is 2 cis pi over 2 plus 2 pi, pi over 2 plus 2 pi, so that is what? Plus 2 pi all over 4. That is 4 pi, 5 pi over 8, sorry, 2 cis, 5 pi over 8. And then when k is equal to 2, similarly, z is 2 cis, 9 pi over 8. I'm just going to skip the steps, okay? When k is equal to 3, z is 2 cis, 13 pi over 8. That is our values of z1 through z4. Okay? And moving on, we're told that z1 through z4, they form a geometric sequence. That means they will have a common ratio. How do we find the common ratio of something? We can find the common ratio to be z2 over z1. Well, this is also equal to z3 over z2, dot, dot, dot. But we're already told that this is a geometric sequence. I just need one term. So I'm going to find the common difference. I'm going to use z2 and z1. So it was 2 cis 5 pi over 8 over 2 cis pi over 8, right? And if I were to divide a complex number by the complex number, what do? I divide the modulus. So from the formula, z2 over z1, the modulus of z2 over z1 is literally just modulus of z2 divided by modulus of z1, while the argument of z2 over z1 is in fact argument of z2 minus argument of z1, right? This is very important. So to solve this, this is cis 5 pi over 8 minus pi over 8, and that means it is cosine pi over 2 plus I sine pi over 2, right? What is cosine pi over 2? Cosine pi over 2 is equal to 0, while sine pi over 2 is equal to 1. So that means this whole thing is just I. So the common ratio of the sequence is just I. Next question, we have z1, 2, 3, 4 represented as ABCD, and we are asked to plot the points. Okay, let's try to plot this on an Argand diagram. An Argand diagram it's basically the same thing as the Cartesian the Cartesian coordinate. It's just a simple axes where we have reals and imaginary there. Bearing that in mind, the z1 was cis pi over 8, while z2 is cis 5 pi over 8, z3, sorry, it was 2 cis pi over 8, and blah, 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 blah. We don't really need to know what z3 and z4 are. Why? Because they have a difference of pi over 4. They have a difference in the argument of, they have a difference in the argument of pi over 2, right? And we just need one point, z1. Why? Because once I pinpoint z1, let that to be pi over 8, and I will call this A, okay? And of course, the rate is this is 2, but we don't have to denote that. Once I know that, I can immediately tell, because they have a difference in pi over 2, and because the roots of unity has to spread out among the full circle, what should the angle between the two values be? They should be pi over 2, which is 90 degrees. So I just need another drawing like that, with the difference of 90 degrees. That's all I need. And just try to, you don't have to be like super accurate, but try to be as accurate as possible so that your lengths of the points, they are approximately the same with the difference of 90 degrees. Yeah, excuse my poor drawing. It shouldn't be like that. Oopsies. It should be like that. It should, my bad. Let me just try it again. Straight line, like that. Yeah. Another way of doing this is, perhaps you can just draw two straight lines because you know that they're going to be different by 90 degrees. Just draw two lines like that, because in that case it will be 90 degrees each. Okay. Yeah. You don't have to be super accurate. This is not art. Okay. But just try to be as accurate as possible. You just also have to denote that this is 90 degrees and this is pi over 8. That's all you need. Okay? And moving on to the next question. We're told that v to the power 4 is a plus bi, and the roots are z1, the conjugate of z1, or the conjugate of z2. So that basically means z1 star is given z1 to be a plus bi. z1 star, the conjugate, is a minus bi, right? So that means I can rewrite v to the power 4 as z1q star multiplied by z2 star, z3 star, z4 star. Okay, I'm going to take all the stars out. z1, z2, z3, and z4 star. Well, what was z1, z2, z3, z4? It was from before. If you remember, it was 16i, wasn't it? So, the conjugate, we're basically asked to find the conjugate of 16i, which is minus 16i. Hence, the value of a is equal to 0 and b is equal to minus 16. Okay? Lastly, our last question of today. We're told that the midpoint of AB is A prime, midpoint BC B prime, C prime, and D prime. So this refers to our Argand diagram. I'm just going to quickly draw. Try to draw it better this time. Oof, 90 degrees, and then 90 degrees. Hope that makes sense. Yes, that they are 90 degrees. And these points are A, B, C, and D. Okay? So that means A prime is the midpoint. Shouldn't be like that. Let me just, if I were to just draw it again. It should be like that. That looks more like pi over 8 to me. While I have 90 degrees angle, that is not 90 degrees. 90 degrees, 90 degrees. That's more like 90 degrees. Okay, got it. So, this is A, B, C, and D. And I want to find the midpoint of AB. This point is going to be A prime. That's A prime. Whew, that was very difficult. Because we know that this is pi over 8, what is this angle going to be? We know that the difference between A and B, this is pi over 2. And so this is nothing but pi over 4. It's a half of pi over 2, right? So our value of argument, the argument of omega 1, I'm just going to call it omega 1 because that's going to be the least possible value of P and Q. Argument of omega 1 is going to be pi over 8 plus pi over 4. That is our argument, okay? And with that, I have to find the, what do I have to find? I have to find the modulus, right? The modulus is, how do I find the modulus? The modulus is basically the length of this, isn't it? It's that length. So, because we know that this is, if I just zoom in to this triangle, okay, I'm just going to redraw this triangle, okay? Oof. Where this is O, the origin, A prime, and A. That's going to be 90 degrees because this is an isosceles triangle, and the midpoint, that means this is a perpendicular bisector, and that weighs 90 degrees. So that means I have this angle to be pi over 4, and that is pi over 4 as well. And we know that this whole thing was 2, the modulus of each the roots of z to the power 4, it was 2. And that means this is 2 over root 2. This is a standard formula, standard angle, standard triangle. 2 over root 2. Well, that is just root 2, isn't it? I'm just going to rewrite as root 2. Oopsies. As root 2. Okay. So with that, I can see that this is root 2. The modulus is root 2. And I want to find what A prime is, right? The smallest value, omega 1, is essentially going to be root 2 cis 5 pi over, 3 pi over 8. Right? But what I want to do is, I want to do WP, omega P, with 2 to the power of Q, for which P and Q are positive integers, right? We want them to be positive integers. In order for it to be positive integers, what do? We have to raise it to the power. We're gonna apply the de Moivre's theorem anyways, but the thing is, we have to get rid of this, don't we? This essentially is what? Cosine 3 pi over 8 plus I sine 3 pi over 8. Our first task is to get rid of the i's, the imaginary part. With that, it will never be represented as 2 to the power of something. So I have to remove that first. That's one thing. And another thing is, I want to find the positive integers. So the argument itself, the real part cannot be negative. That means the angle of the cis thing, this should be a multiple of 2 pi. In order to make it a multiple of 2 pi, what do we need to multiply by? The least possible value. It would be 16, wouldn't it? If we raise to the power of 16, by the DMT, the de Moivre's theorem, it would be 2 to the power of 8 cis 6 pi. What's cis 6 pi? Well, we can just express this, then it will be 2 to the power of 8. And hence, our value of P and Q are, P is 16, while Q is equal to 8. That's how we show our answers. This was a little tricky, where you had to go back and forth. The hint is that the IB always leads you the way. So that means that since this is part E, you will kind of have to use what your answers for part D and part C is. So you can refer to those. So from there, I got the idea of the Argand diagram. After drawing this, I try to find what the radius, the modulus is. Okay, and the argument itself from the Argand diagram, I try to visualize it, and then finding the argument, finding the radius, I try to express it, okay, and then I try to make it the whole thing positive integers, removing the integer part, removing the imaginary part, and making a non-negative number. And the smallest number we can multiply this by was 16. And that's it for today. That's all for section A and section B. It wasn't too difficult, I don't think. Yes, so all the best. Bye.